So I haven't been out to like headquarters and do a kickoff like in Annapolis. You guys think it's? Yeah. Like 4 years ago. Oh, 3 years. Yeah. So it's just there are people I don't know, and it weirds me out. Which I should really stop feeling that way since we're only 75,000 people.
All right, looks like we're good to go. So thanks everyone for coming to my talk. This is actually really exciting for me to be here, especially after starting out the week talking at an IANS conference, which if you haven't been is all CISOs. So it's a completely different room and all just manager types trying really, really hard to look serious. So be here instead in t-shirt and jeans and a couple bourbons in is just way more fun. So I'm here to talk about OpenAppID, which is actually the latest thing we've added to Snort. Right, so we're going to be talking about application identification, how you can do that, and start doing it right away because it's free and open source. Right. All right, so that's what we're covering here. Is this what's latest with Snort, what we've put into it, and released to the community. Let's see. Yeah, biggest change from putting together my slides in the presentation at the beginning of the week. Usually, when I was doing this con, I got all my content together, and then I was done. Whereas speaking to all the managers, I had to get content together, then spend twice as much time looking for stock photos to make the slides interesting, because those have to be in there, right? There has to be a guy writing on glass. What's next? I mean, let's see. This team is great, right? They're thrilled to be doing their jobs. I mean, you got to show. I mean, some decisions are hard, right? It's a very, very serious game of tug of war they were playing, apparently. Got to have the keyboard. If the focus is adjusted, it's completely arty and serious. All right. So getting to put this together has been just a lot more fun. So thank you all for having a con where we can just sit here and talk like people. So we're talking about OpenAppID, which is actually the application identification layer for Snort. All right, so this is something we've been working on for a long time, sort of had sold on the product side. And did I have yeah, by the way, I'm Adam. I'm an engineer working with Cisco, hired by Cisco as a part of SourceFire, right? What we're talking about today has to do with Snort, and it's all wrapped up there. And yeah, we sort of sell commercial versions of it. Everything I'm talking about today is the open source version, though, right? This is in no way a sales pitch. This is all stuff you can go download right now and try out. So where was I? So we're doing OpenAppID. So what we have is another layer to Snort, which is in charge of watching traffic in order to identify applications, right? Snort has a number of preprocessors, if you ever worked with it before, to shape that traffic, to understand that traffic, right? First, we have to understand, okay, is it IP traffic? Well, if there's fragmented IP, we want to put it together, right? Then that's going to go through a TCP stream reassembly, so we can understand how that works. Might then go to some application layer stuff, right? Like if it's HTTP, we want to normalize that traffic. Another layer to that process now is application identification. You can now add the Snort engine. So as we're processing this traffic, and before it even goes to the rules engine to start looking for threats or whatever we've built rules to look for, we can layer in application identification. This is now completely open sourced, right? So you can get the detection module, what's actually doing all this detection. The detectors themselves are open source. You can download those. So you can literally grab the latest version of Snort, still in the beta version. So the latest beta version that's up on snort.org, and you can have applications that like a layer 7 firewall going just with the free software we've got out there. Okay. So what I'm going to do is talk through, okay, well, what exactly is the next-gen firewall we're getting out of it, and I know, just as enough why I was brazen enough to call the talk in open source NGFW. And then get into OpenAppID and what we're going to do there, right, as far as how do you install it, configure it, what kind of data can we get out of it, And then once we understand how application visibility is working, how can I get application control? All right, so now we can actually turn that around, and if we've got Snort deployed inline, we can start blocking all of the applications we can identify. All right, and then I'll actually show, depending on how fast I talk, right, some of the data visualization that's actually really easy to get out of this, right? So you can very easily turn up a dashboard and say, okay, well, what applications on my network are using the most bandwidth, right? What applications are deployed the most widely on some of those things? All right, so what's the difference between a product with a new feature and a next-gen product? Marketing. So let's stop for a minute here and just say, okay, well, when I say it's you can do an open source next-gen firewall, what am I really talking about there? I think that's worth defining. So for the record, I'm using Gartner's definition, which I think is most widely adopted, which blah, 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 boils down to I've got a firewall, I've got IPS, and I'm doing this application layer visibility, right? So I've got traditional firewall, application firewall, but also doing IPS. I think the IPS portion is what some people are arguing about. But for the most part, it's saying, yeah, no, we have to include the IPS because building a better, higher perimeter wall isn't enough, right? We also have to be threat-centric. So if we're going to do this, we need, yeah, a regular firewall. And if you're going to do that open source, I mean, that's nothing new, right? How complex do you need it is really going to be the only question. I mean, so I was putting this together. There's this UGFW GUI I launched right from my Ubuntu box. Cooked in a couple of rules. Here's the ports I'm going to allow. I was done, right? If you need something more complicated, sure, Wall will do it. You can manage firewall that way very easily. A little higher learning curve, but great tool, right? So with that IPS component, by the way, also nothing new there as well, right? Snort is de facto standard in IPS. You can get that open source for free, get that up and running to actually look for threats. So what's new here is that layer 7 component, right? So how do we do application visibility and control? How do we say, okay, yeah, it's great that I'm only letting things through on port 80, 25, and 53, but it's a lot of stuff, right? So how do we get deeper visibility into that and actually see what applications are out there? How do we stop an application without saying, like, well, I guess I can't actually block port 80? Does that mean let everything through? Or can we again start saying, okay, these applications should be blocked? And that's what OpenAppID is for, right? So it's about doing that layer 7 detection and control. And that, by the way, is completely open source. And to point out, this was released as open source after Cisco acquired SourceFire. For real. So, because as soon as the acquisition was announced, a lot of the open source people started screaming that the sky was falling and Cisco was going to ruin everything and Snort wasn't going to be open source anymore. Which, to be fair, is an accusation they make every couple of months for some reason or another. But Cisco has actually reaffirmed that they're going to stick with the open source model because they know it works. I think they've accepted, they don't know how, but they know it works. So they're sticking with it, all right? So not only are they leaving Snort open source, but even more is open source than before. So all of this application detection ability, as well as all the, I shouldn't say all, I don't think that's true, but a great deal of the detectors we've written so far have been released open source already, and more will be, especially as we get to a regular version launch instead of the betas we've had over the past couple months. All right, so this works as a preprocessor, which we already went through. So we're just going to add that in. If we've got the latest version of Snort, we can now set up Snort to configure to use this new component, right? There's a couple other new requirements I want to point out. And the first is that you have to have like the Lua just-in-time libraries installed. The application detectors that we have are written in Lua. So we have to have that available on the box. When you compile Snort, we need all of those libraries available. And then if you know a little bit of Lua, you can go in and see actually how these detectors really work. If you know any programming language, you can actually open it up and see how they work. I don't think I could write a hello world in Lua, but I could, I've written application detectors. Because if you've seen code before, copy and paste will get 90% of the way, right? And the other thing we want to grab is the application detector package. So like if you go out to snort.org, you'll see not only the latest version of Snort, there's the rules, but now there's application identifiers, right? So that's a whole other separate package you can download. That has a couple of the libraries you need to run it, as well as all the detectors themselves. So you can see those, by the way, they are these Lua files. So you can literally open up these text files and see how these detectors work, what it is they're looking for. Okay, what in the packet are they looking for? Are they looking for this URL? What are they looking for in SSL here? And you can see how all of that works, right? So this is completely transparent in the same spirit as all our Snort rules, right? They're there for you to see. You must have some of the other preprocessors on. I point this out as a requirement just to be technical. You know, you have to have IP, fragmentation, stream reassembly, and HTTP preprocessors going already. But by the way, these are on by default. Like if these are off, you've either heavily customized your environment, or you really screwed something up. So this shouldn't really be something you have to worry about. So then we just have to really get into your snort.conf file, right? If you haven't worked with Snort before, almost all the configuration is done in snort.conf. It's a text file and everything we want it to do and all its configuration options, right? In that, you configure all the preprocessors. So all the really big change you need to do to get it running with OpenAppID is you're going to add like these few lines to your configuration file, which, I mean, if you want the slides, you can have them. This is all in documentation. So none of this is like a secret. But I just want to point out all the steps here, right? So we're just going to tell it, yeah, I want to turn on App ID. Then I want to get the, I want to start collecting the stats, and I'm going to tell it what log file those are going to go to, how often you want to spit that data out to the logs, and what directory you're going to find the application package I just mentioned before with all the detectors. So wherever you download that to, you give it its directory here in your config file so it knows where to find them. Right? So once you've done that, you can restart Snort, and you should be detecting applications and all the traffic going through it. All right, so if you want to look through the application detector package, you've got the actual Lua scripts in there. Like I mentioned, there's a small files on port detectors. Like there's a couple of applications that are identified only by what port they're on. It's this real simple file. There's a handful of things in there. You can look at that. And then there's this app mapping.data, which I'll actually show you because it's a good way to parse through, okay, what detectors do you already have, right? So this has them all mapped out. What's their name? What's their ID number? So if you wonder, like, hey, can Snort detect this? Grepping this file is usually the fastest way to check, right? And I'll show you that in a second. And the way that those directories are all laid out, as long as you're pointing Snort to those directories, it's going to know about it. You can also create a custom directory in there, so if you start adding your own application detectors, it will read them from that custom directory, right? Again, I'll show you that here in a second. So not only do you have all of the detectors that we've released already, but the idea is it should be really easy for you to get in and write your own. So if your company has a custom app, which of course we'd have no reason to write a detector for before, it should be pretty easy to go in there and customize that and get it up there. So you could have in your application statistics dashboard, everything show up as your custom app instead of just, you know, generic HTTP or whatever it is. Also to point out, I think a lot of the benefit there is we're going to see is, you know, hopefully if this is adopted as a standard the same way Snort rules are, is that we're going to see a lot more people coming to us and saying, hey, we want a detector for our software. Which is something we started to see in, say, like manufacturing industry, where we've seen a big kick up in people wanting to put IDSs out in like SCADA environments and such, right? Well, we've seen more people, if this is going to be an open standard, then we want on board, we want our stuff detected. So not only does it mean you'll be able to add your own detectors, but it should mean that the availability of all of them are a lot easier to get, right? Because more people contributing, so that even if they don't want to get involved with SourceFire, a commercial product, then maybe you just pick another detector up off the mailing list the way you would a Snort rule today, right? All right, so as traffic's coming through here, this application identification module is going to be able to start profiling that traffic. And for every network connection going across, we might actually be able to identify 4 different applications, right? So for any given, say, TCP stream, we might pick up 4 apps, right? So there's like the service app, the client, the payload, which might be embedded in that, and then maybe even miscellaneous. So if I go out to, say, Facebook, I might actually get an app ID result that comes back and says, well, the service app is the Apache server that it's running on. Client app is Firefox. Payload app is Facebook, and maybe miscellaneous comes back and says, oh, you're also doing Facebook chat, right? So we'll actually see a lot of that. So for a web app, you could actually see a number of things. We could actually see, okay, well, there's, this is the web server, this is the browser. I see HTTP, as well as possibly a web app if it's one we've seen before, right? All right, and we do want to point out that the output here is going to be saved in what we call a unified format. It's really this standard. Everything should be saved to unified. If you've configured Snort in the past, perhaps you've seen that there's a lot of options. Like I want to output to unified, maybe I want to output to syslog, to MySQL. What we're really sort of pushing towards is everything being saved to unified format. It's a compact binary format. It's the fastest we can write to. The idea being, once we write to a unified format, then you take it and write it to a database or to syslog or wherever else you want it, so that the Snort process itself can be as fast as possible. All right. So it is saved in a binary format, but if you look, when you unpack Snort, right, if you go out here and download the latest one, there's a tools directory in there, and that has a number of utilities that will convert that unified format into a text format. Right. All right, well, let's just. All right, so let's actually take a look at some of that. Let me close that down. All right, so I have this configured. Snort's up and running. You can see, okay, it's processing packets. So if I generate some traffic here, okay. If I can get online, yeah, that's a good idea. All right, well, I'll have to think about that. Could have thought, yeah, Wi-Fi off is probably a better way to go about it. All right, so I'm going to look at that live. Let's see what I've got in here already. All right, so if I've already got Snort running and it's gone through there, you'll see I have a couple files it spits out. I've got snort.log here, which is my IPS alerts, right? So what it's already created, what we're used to seeing from it. But you see I also have this other file, appstats log file. So here's the application statistics we got coming out of the application identifier. So one of the things that's packaged with Snort now is this U2 OpenAppID program, which will convert, again, that binary format into a text format. So if I run that on the latest appstats, we get this results, which is really small. Okay. So you see in a single network connection that we've identified, okay, Firefox as a client, it's using HTTP as a protocol. We've hit DerbyCon because it's a custom app. I'm going to show you. Here's an example of how easy it is to write your own, as well as the DNS request to go out there and get it, right? And then looks like it did that twice. Again, Firefox uses HTTP to go to DerbyCon. And then we saw another DHCP request happening. All right, so in the course of the last time I ran Snort, when I was having some internet access safely in the confines of the hotel 2 blocks down just so I can have internet at night, I was able to generate some traffic, right? So this is completely in addition to the normal logs we're going to get out of the IPS component of Snort. This is going to be just to tell us what's going on. So we see that for every application, I've got, first, of course, a date stamp, the application name we've collected. In this case, here's Firefox. And then you see the number of bytes transmitted and received. So not only do I know all the applications that have been running on my network for this time period, but how much traffic they're generating as well. Okay. All right. So the example here is actually just going to CNN.com, which is pretty interesting because this is all the network connections it took. Because now we see, okay, we saw Chrome use HTTP to go to CNN.com after we saw a DNS lookup, but then we see connections to DoubleClick, to Trusty, to Washington Times, to Turner Broadcasting, to Moat, and I think it got cut off. I think there's a couple other spyware things embedded in there. All right, so we'll actually see all that. Do you have a question? That's possible. If we collect the data like from the IPS component, we'll have everything. The application stats themselves are just the amount of traffic in the application name. But in a second, I'll show you the IPS output, which is all your packet header information as well as like the captured packet itself. So if we really want to dig into it. So maybe not user, but certainly IP addresses. We can get that. All right, so there's a couple apps in there to convert those files. Again, here is the output that would come from an IPS alert. Okay, so if we see that, what sensor is it coming from? When did it happen? Here's all our header information. So here's the IP source. Shouldn't click it. Destination IP. There's our source and destination ports. What protocol is it? But you'll see the new field here in bold is this app ID, which is actually telling me this is a packet headed to Reddit, right? So it's identified that as the application. That's now included in the IPS alert, right? So for any traffic we've already identified, that's now included as part of the metadata for that connection. Yeah.
Is there a way to find out what browser Reddit used or like multiple app IDs?
Yeah, right. So if you take a look here. When I found, so say instead of Reddit, we're looking at CNN.com, then I'm going to look for the time. Generally, everything happened in the same connection is going to have the same timestamp. So if I filter just based on that time, it's going to narrow it down. Maybe on a large network that would get problematic. But as we see here, at least, we're going to see, okay, there's Chrome running at the same time that it's hitting there. I guess I haven't pulled the raw data for a huge number of users at a time. That would get more problematic, so we'd actually have to go back to correlating that with the connection results we're getting from it, instead of just using the application stats, which is a bit more generic than what data we can pull out of the IPS, right? And to show you, we're also pulling some additional data out because a lot of people are still using some very, very old GUIs to look at Snort, unfortunately. But if you actually use some of the latest tools, you actually get a lot more data than you'll typically see just because there are new fields that have been added since the GUIs were last updated, which people are still using base, which was last updated like 5 or 6 years ago. So in this case, we'll also see like the HTTP URI and host name that we've collected there as well. All right, so another thing this does is actually provide that application ID information to the Snort rules language. So this is a component you'll be able to use if you're writing a Snort rule, is that you can include app ID. So if you wanted to match all traffic going to a certain application, or if you were writing a rule looking for a vulnerability in a specific application, instead of doing a lot of other qualifiers to say, hey, only look at these, we can take all that work and say, okay, I know I'm looking for a vulnerability in this application, we'll just app ID, there it is, and now I'm already constrained to only look at that traffic, right? So there's a lot of different keywords to the Snort rules language, right? I want to look for this pattern, I only want to look for this protocol, whatever it is. Now we'll have the app ID keyword as well. So if we're doing application control, if we want to say, okay, not only do I have all this information, what statistics I'm getting, what data I'm looking at on the network, I want to start looking at blocking this traffic. Well, if Snort's deployed inline, we're going to have that capability, because now we can take that app ID information, use it in a Snort rule, and say, okay, drop any traffic that matches this app ID. It would be problematic as a whitelist. But if there are apps you absolutely wanted to block, then you could do that. Yeah. Right. So if we're having productivity issues and we need to block some certain apps, well, we want to write a rule to do that. It's really pretty simple. I mean, if you were going to do a Snort rule without all the new application identification, we have to, I don't know, go get a PCAP, take a look at it, see what else to block. But I know that app ID already identifies Reddit and Facebook here. So if I just want to turn around and start blocking those, all I got to do is, first of all, find out what Snort's name for them is, right? Because we have a name and ID number for each app we already have. Well, there's that app mapping, that data file. Take a look at that. There is, yeah. It's this file here. So if you look in the application bundle you can get from snort.org, it includes this app mapping.data, which is every detector we have, its ID number, and how they sort of structure together. The idea being now, if I search through this, I'm going to see, okay, what detectors are available. So if I do that again and say I want to know what Google apps I can identify. Let's see. Some of it. Oh, what the actual command was? All I'm doing is searching the file. Yeah. So I just grepped this giant list of all our application identifiers for Google to see what came up. And I can see all the different ones we identify. So these can all be identified as separate apps, right? So if I want to block Google Earth or Google Reader, I can grab their application name here, put that in a rule, and now I can start blocking them, right? So these are the ones that come back for Google. If I wanted to see what other apps are out there, now we can start searching that, right? So once I've got that name that we've given it, I can put it in a rule. So here I've written as simple a Snort rule as you can do. Of course, you can be more complicated, but I've just said, okay, look at TCP traffic going anywhere from anywhere, and if it matches this app ID, you can see that the only new part here, these three words here, app ID, I've got Facebook, I've got Reddit, it will match either of those. So you can actually put more than one application ID into a Snort rule, up to 10 in a single rule. So you can put that in there. Of course, if I want to constrain this anymore, I can. If I want to only block from, say, a certain IP address or range, I could limit it instead of it being any. I could have been nicer. I could have blocked just my stuff from going to Facebook and not also my girlfriend's. She doesn't know about Reddit. That wasn't occurring. Thank God. But so we could have constrained that a lot more. Yeah.
Are there some larger groups like social networking where Facebook and Reddit fall in and you use to get around the whatever?
Yeah, because it will also, like, how specific do you want to get? So if you look at, I mean, Facebook specifically, there's actually a few that come back. Let me see if I can just do here and look at Facebook. So you can do just Facebook, which is everything Facebook. We could do Facebook apps, which is just like those embedded applications. Facebook commenting, whether you're going to search, whether you're going to post to Facebook, whether you're going to do video or games. So those are also identified as sub-applications. So I can actually allow people to go to Facebook and block them from posting or chatting on Facebook, right? Depending on how deep we can get into any given application, right? So I don't want to block all on Netflix.com, but I want to block people from streaming the video. Well, I can do that, right? I can identify Netflix streaming as just an app in and of itself. Well, it's somewhere in there. And say just that one. Yeah.
Since a lot of this is going over TLS, some of the identifiers for the technical application is using like US hosting, that sort of thing, you know, it's chat or it's hosting.
That's a really good question. So for Facebook, a lot of these sub-applications, it can't identify if it's still encrypted. A lot of these were built on the idea that they're going to be decrypted before they pass through here. But it depends entirely on the application you're looking for. When you look at the Google sub-apps, the majority of those will work still encrypted because we're actually able to build the detectors around what we see in the SSL like cert name. All right. Now that happens because Google is goodly enough not to use one cert says Google. They actually have a different cert for every application. Right. Yeah. So we can actually identify that even though it's still encrypted. Question in the back. The data we're collecting? When you configure it, you set how long to output it, or how long between, right? So the default I have is like every 60 seconds it outputs that data. It also comes with an application called U2 Streamer, which you can actually set up to run, to automatically configure that into like a syslog format. So that would actually stream live. So you'd still be getting like 1 minute intervals, but I could also lower that down to run every 10, 20 seconds if I really wanted. I don't know how close to real time you're really going to get without a performance issue, but I mean, pretty close. Is that what you're asking about? Did I answer your question? Okay. Yeah.
I think that brings up another good question about Barnyard too. Is it going to be integrated in the Barnyard processing or push it to the databases? Maybe some existing interfaces?
I believe it already is, but I need to double check that. If it hasn't already, it certainly will be. Barnyard's really easy. It's already set up to say there's the core of the snort message, and then there's in the unified format there's also what we call like an extra data header, and that's a fairly flexible format, and that's where you can get like the host name and some of like the HTTP information we grab. Barnyard's far more up to date on that than a lot of like the GUI programs that actually parse that data. So if you're okay looking at the text information, my guess is you can start looking at that like tomorrow. If you're piping this to a GUI is where people start to miss some of that information. Okay. All right, so I've got this rule now. If I change that alert to drop, now anytime we see an application identifies as Facebook or Reddit, we're going to drop that traffic. They're not going to be allowed to get out to that application. Right. All right, so another part of this is that because it's open source, we're going to be able to do a custom detector. So let's take a look at what it would take to, say, write a custom detector for DerbyCon and see who's going to the website. One option to doing a custom detector is, again, just port. If you just want to say, hey, anything in this port is this detector, you can. All right, it's a very simple little like YAML file. You literally just say, hey, here's its name, here's what I'm calling it, this is the protocol you should look at, here's the port, and here's the app ID I'm going to call it. So if you just want to do it by port number, you can do that. But, you know, let's look at something more interesting, right? We're going to do custom detection. Let me start by showing you an example here. Here's an example of, let's see, a colleague wrote this one to monitor all traffic headed to a couple different craft beer sites for festivals in the Maryland area. Right? So if you see all that, it'll come back as this application here. So first I'll just show you what the entire thing looks like. What I'm going to do now is break this down into different sections it is and convince you that most of this is structure. And that if you wanted to do your own, it would be fairly easy to copy this, paste it, and change a couple of things to get what you want. So here are all the different parts of a custom app detector. Right? So we got the information header, the libraries you want to include, the detector package, which almost never changes, is just, okay, load this Lua library. And then you could have the initialization, validation, and clean functions, which are really, here's what I'm looking for, here's how I want to identify this app. And let me break those down, right? So that information header is literally just a comment. It's a multi-line comment, so you don't actually have to include it at all. right? If you're going to send it out to community, it'd be great if you did. But it's just, okay, here's its name, here's the version I'm looking at, right? Here's a little description. But that's all that is. So the first, 5 lines of the giant here, 4, sorry, that's all that was, right? So the little multi-line comment at top to say, okay, what is this? What is it doing? Next section down is the included libraries, which more often than not is just these 2 lines here. Require this detector common, which again is a library we distribute with that application detector package. So it's got those 2 lines. Now, if you were going to write some real fancy application detector and needed your own other library, you could also load it here, right? All right, so next is that detector package information, which you're going to give the application name. You're going to say whether you're going to specify its protocol, right? You know, TCP or UDP. And then for client or server traffic, you're going to specify its initialization functions, detection functions, and clean functions, which is your way of saying, okay, here's how I want this detector to load. Here's the detector I want to actually parse this out and do the detection itself. Okay. Now, the initialization function is called when the detector is loaded. So you'll do this, create app function, which literally just pulls an app ID dynamically for you, so it has a number, the same as the ones we generate. And then here you can load your fast patterns, as well as any patterns you're going to match in HTTP, SSL traffic, or SIP traffic, because those are all parsed by different preprocessors to Snort. It's just saying that since we're already pulling that data out, we're going to look for those in the initialization functions instead of the later functions, which are what do we run on each packet going through to see if it matches. We don't need to analyze every packet for HTTP information because part of Snort's normalization process is to already grab that information. So if all you're looking for is the SSL cert name or something in the URL, we're just going to load that in the initialization function. That's really going to be all we need. The validation function is, okay, what do you want to do? Okay, yeah, I'm starting to match this, but do I want to now dig through each packet for validation, right? Do I want to check the size of each packet? How many bytes are in there? What direction is it going to? Does it have this pattern? So if you really want to get real deep into identifying a new protocol or something like that, this is where you'll build that out. So you can do that. You can set values across different packets that are a part of the same TCP stream. So you can really look at how are things changing across multiple packets as it builds it out. And there's a lot of functions there, same like if you're running snort rule in C, right? So if you want to pull out any of the information we've got about the packet, if you want to use C to analyze any of the information we've collected in that packet, that's all there available to you. And then there's also a clean function, which I haven't used yet. I haven't needed it. You can use it to clean up at the end of a detection. With Lua, you don't need to do any memory management. That's already done. But I guess if you wanted some debugging output or some statistics on usage, you'd output them here in the clean function, right? So what I did was grab a very similar application detector. I copied it and I started changing stuff to detect DerbyCon, right? So here's the detector package information and the first part of this detector. All I really need is the first few lines are the same in everything. I give it a name. I make sure it says TCP. And then for my different functions, I'm saying, yeah, I have a initialization function, and I'm not even using the validate or clean functions, so they're set to null, or nil, as it happens to be in Lua, right? So all I'm saying is I've got a name, and here's the function where I can use my initialization to set the patterns I want this to look for. All right, so I change those. And then I actually write this little detector init function, which again, there's a lot going on there, but the heart of it is really just this line here. I'm using this add URL pattern function to say I'm looking for DerbyCon.com, right? That's all I'm looking for. That's just really the one line I needed to change in this to add my own custom application detector. Or if I want to add a whole nother one and say, okay, instead, let's also add a different app for anyone who happens to be looking at the schedule, we could do that as well. So I've added another line here to say, okay, if they go to DerbyCon/schedule, we'll actually identify that as a different app and log that separately. right? So there's another function there with a different URL. App names have to have less than 16 characters. That took a while to figure out. So I'm just pointing that one out. All right, so I've got all that built out. I've got my DerbyCon.lua script. I'll put that, again, I've got that application package I downloaded from snort.com. That I'm going to create this custom /lua directory and put it in there and restart Snort, and now I'm detecting that, right? So sure enough, that's what we had. Again, I'm not risking getting on the Wi-Fi to show this live, which I know is a little sad, but if I parse the output I collected earlier, again, we'll see DerbyCon picked up here as an application, right? Not included in the default, but I had this custom script in there when I was running it. So we're picking that as a separate application we'll be able to track, right? Do what? Oh. Gotcha. All right. Good enough? Okay. All right, so we see that I used Firefox over HTTP to go to DerbyCon right here. All right, so that's the output we're going to get from OpenAppID. Now it's watching that traffic. That's a good question, right? No, you don't. We have that large mapping for every application that we create and put out. So if something gets adopted as an official app, it'll get its entry in there. But for custom scripts, what you're actually doing is you use a dynamic function to say, get me an app ID number. So when Snort starts up, it's actually going to dynamically get a number that's not in use. There isn't, but all the data reports the application name and not the ID, right? So you shouldn't actually need it, right? All right, so there's the output we're getting. What else can we do? If I really wanted to improve the DerbyCon app first, the next thing I'm going to have to do is realize that actually once you get to DerbyCon, it redirects you to SSL. So if I want some good stats on how much traffic I've got going to DerbyCon.com, I've got to go back into that application detector and add not just my add URL pattern, but my SSL cert pattern and track a cert for www.derbycon.com. And that way I'll actually be able to track that traffic as well. So again, I can't see into the encrypted traffic, but if I know the cert name I'm looking for, I can grab that and use it. All right, and a lot of this output, by the way, is built for easy parsing. So you see, like, yeah, it stores as that binary format, but it outputs it here again to this format here, where we're sort of specifying each variable. Here, app name equals, right? So if I load that, so here we have a, waiting for input. This is a completely empty Splunk instance. I VPN'd, figuring I wouldn't have an internet connection. I got some more data. I VPN'd back to the home network and grabbed the stuff off of my Snort sensor. Might be a really bad idea. Screenshot. Actually, we'll just skip that step. We'll say skip preview. We will trust Splunk on this one. Oh, here's my file name. Change that. If some of you are familiar with Splunk, I'm sorry for causing you to roll your eyes. I started playing this a few days ago. Which, there's some value there, right? This was actually this easy to get up and running. It didn't take me long at all to take the data I had from OpenAppID, literally just point this at it and get it indexed to the point where I can start visualizing this data, right? It's mostly an excuse for me to start playing with Splunk. But this is really great. I mean, I've done a lot of my visualization in R, but that's way more difficult. This is actually really, really easy to get up and running. So let's see if I refresh this, see if I've got my data. Yeah, so I've got 40,000 events indexed here already. So if I just take a look at that, okay, show me all my data. Looks like Snort was not running for a few days. But I've got data from the past couple days and then a few days back. So you can see here as we start to look through it, it's actually figured out my different fields, right? And imported this, here's one big event, but it also can pick out my time. You can see it picked out app name. Oh, geez. Let me see if I can zoom in here. No. Thank you. There we go. Okay, so if I look, actually on the side here, it's already pulled out my fields that identify them already. So here's app name, it already figured that out. I can see what are the top values, and it's going to load that up. And we can see, so it looks like the top application is DNS. Well, that's just by number of connections, right? Not like volume of traffic, right? So yeah, each log entry, each the connection figured out there. So there's DNS, HTTPS, HTTP. Apple sites comes up at the top. There's Safari, Netflix, Hulu. I know what girlfriend's been doing the past couple of days. I haven't been home, but looks like, again, this might be a bad idea, but I don't have a lot of relationship advice, but not poking around your significant others, your web browsing history might be a good idea. But hey, for all of you, let me open up. Or instead, I've got my traffic. So transmission, probably not anything. We're looking at a lot of streaming media. So let's say maximum over time. Well, here's the bandwidth usage I'm looking at over the past couple of days. So here's a giant spike. If I want to know more about that, well, if I just go to my search thing and say, okay, well, show me by app name, it's actually going to split that out. Now we can start and take a look here. Okay, what app is using all that bandwidth? Mac App Store. Over HTTP. Apple app. Yeah, so I have a ridiculous number of iOS devices in the house. And that's about when iOS 8 came out, right? There we go. That's where all my bandwidth went this month. All right, so if I want to start digging into that, we can do a lot to take a look at that data. And of course, once I'm in here, all this can be saved as a dashboard. All right, so if I want to set this up and just like log in and take a look at, okay, what are the top apps on my network? How many apps are on the network? All right. What's using the most bandwidth? Again, anytime you've got a neat graph here in Splunk, I can just like go to Save As and then add it to a dashboard panel. All right, so it'll save that and run it, right? Are the Splunk people here? I just feel like I should get a kickback. They have a table. I don't think I saw them, but so no, that was actually. It took me like a few hours to get this installed, get the data in there, and get a few pretty graphs put together on a dashboard. So that was incredibly easy. I don't know how easy it is to do anything more advanced than this, but man, to do the basic stuff, that is just brain dead simple. All right, and all the data is set up to parse like that. So if I want to take a look at all the applications that are on my network, what they're doing, that's pretty easy to do. All right, so I've got transmission and receive bytes separately. I can actually just tell it to create a new field called total bytes by adding the two together. Pick that up. So I run that, now I'll have that information. You'll see it's added as a field here, total bytes. if I want to chart that, say the total, differently for each application. All right, now it's going to give me a list of all the applications it's seen on my network. It looks like there's 228 different applications seen on my network in the past week, right? And I can now have the total amount of traffic for them. And let's actually sort that. All right, so again, here's another thing I can say in my dashboard. Which apps are using the most traffic? Well, HTTP, yeah, it's the top because it's fairly generic, right? All these things could also be, like Apple Update, probably also HTTP. So there's my Apple Update, Mac Store, there's Hulu, SSH, Open SSH, Apple Developer, there's Pinterest, yeah, girl loves Pinterest. All right, so there's Facebook, iCloud, Java, it's picking up, Adobe software, at least that's getting patched. All right, Netflix, Tumblr, BuzzFeed. Yeah. Wait, what did I just do?
So let's say Facebook's doing a bunch of stuff over HTTP. Is it going to run it twice, or is it only getting
I'm not sure I know that. Well, I think it might be both. I believe it's going to fall into HTTP until it's identified as Facebook. What I don't know is after that, does it count to both or just one? That I'll need to actually get clarification on. All right. But for a certain part of that, before it knows it's Facebook, it definitely knows it's HTTP, and that gets logged there. All right. Yeah. No, only if you want to block. Yeah, all this can be done passively as long as you don't want to actually start blocking those applications. So everything I showed you, except for the exception of writing a snort rule to drop traffic, all this can be done passively inline. If you want to take a span port, or if you've already got the PCAPs and just want to pass it through snort this way, you could do it. You could do that as well. Oh. Yeah. Yes. No, I don't know of any reason an IPS would have to be inline unless you were decrypting the traffic without the keys. You said it. I got a pretty good idea. You have another question?
So what about using the App ID block while it's in passive mode with request for cascade reset? Can you do that?
That's possible, yeah. I guess I haven't spent any time thinking about it because we really don't recommend it. The idea being that, yeah, okay, if you want to do a block, can I send out a TCP reset? Yeah, it's just that you get that race condition, right? Like, yeah, I sent it out, but I have no idea if it worked, right?
Still better than maybe just completely passive, right?
Depends on kind of. I mean, like, yeah, maybe you block the attack, but your security analyst is still going to have to go and check because you're not going to know if it was blocked or not. So at the end of the day, we tend to err on please don't create a false sense of security. Let's try and, I mean, if it's the only way we can do it, that could be jury rigged. But please don't. Yeah, it's a common like, oh, just do TCP resets. I don't know why that idea won't die, but it's out there. Yeah, it's not a good idea. It's just that there's so many security people like, well, stupid networking people won't let me. How do I do anything, right? Yeah, I get it's a common problem. It's because it's a common idea doesn't make it a good one. So yeah, you could actually do that, but try and find another way. Yeah. Okay. All right, so if there's any other questions, I'll stick around and answer them. Otherwise, thanks for coming. And I have a couple of flyers up here for a party I have a bunch of Cisco money for. We're doing just down the street. So we have an open bar if you want to stop by. Grab the flyers up here.